All right, so we start with the, we have started the studies of econometrics. I'm sure maybe the red marker is clear, isn't it? Are you able to see the red marker? People are not responding.
When the mute, yeah, we are able to see. It's very clear.
Okay, thank you. So let's start the econometrics. We start like this. So in econometrics, what we just do is to study the relationships between the variables. I'm sure you, those that might have ideas or that might have done this course already, you can attest to the truth that what we are doing is just to study the relationships between the variables or among the variables, of course. We are studying the relationships. So what has actually happened is that, what usually happens is that the world is inquisitive of knowing the relationships that exist among the variables. We are interested to know how the variables affect each other, all right? So most of these variables that we look at are qualitative in nature. So hence the need of econometrics to quantify the same what? The same relationships. We need to quantify, to have the study of these relationships among the variables that is quantified. So econometrics comes into play to help us to understand the relationship among the variables, especially in a quantitative way. That is what econometrics looked at. So with econometrics, we will look at the relationship, for example, between the variables. Let's say you want to study the relationship between temperature, right? You want to study the relationship between temperature and the sales of ice cream. Ice cream. Let's look at what happens. Okay, which variable influences the other variable? If I'm to pose a question, is it the temperature that affects the sales of ice cream, or the ice cream sales affect the temperature?
The temperature.
The temperature. Madam Nyambe, what do you think?
It's the temperature.
The temperature is the one that influences the sales of what? Of ice cream. The higher the temperature, maybe the more sales of ice cream we have, and vice versa. So those are some of the things that we try to look at. So when you look at these things, you find that there is one variable that tries to influence the other variable, okay? There'll be one variable that influences the other variable. So the variable that influences the other variable is called an independent variable, okay? It is called an independent variable. Whereas the variable that is influenced is called a dependent variable. So the variable that you are trying to determine how it is influenced by the other variable, it is called the dependent variable. You will be interested to study sometimes maybe the relationship or what it determines. Let's say what determines the salaries, right? What do you think it determines salaries of people? What are some of the variables? Maybe we start from there. The introduction is very important. You have to follow. What determines salaries of people in these places of work?
I think it's a skill.
Okay, let's say education, number one. What else? Any other?
Sorry, I didn't get the question clearly.
The question is what determines the salaries? Okay, what influences the salaries at the places of work, for example?
Qualification?
Qualification, let's put it under education. What else?
Yeah.
Any other variable?
I think the skill.
The skill, let's put it under education. What else?
The hours, correct?
The hours for work. What else?
Age, maybe, I guess.
The work experience, right? The work experience, you cannot forget it. Very important. The age, to some degree, people have said the age matters, isn't it? What
Yes.
else? What else do you think matters? Does the gender matter to some degree?
No, I don't
No.
think so. Don't think so.
Okay, now those are research questions. We will need to find out if gender matters. You don't think so, but we don't know. You have to test whether that matters. Let's assume also the gender does what matters. We are just assuming. So what is there is that these are the variables that are there, okay, trying to influence this other variable, which is called the dependent variable, the Y variable, right? The salaries are a Y variable. They're the ones that are influenced by what? By these other variables. And these other variables are called independent variables. Okay, they're the ones that determine the outcome or the result of the dependent variable. And that's what usually happens. So you have these questions in real life. Okay, what determines maybe salaries? You are interested in knowing. Okay, you see those deviations in salary. What really determines that? Those are research questions that you formulate. And then you go out, you sample data, you look at the variables that you think they influence, and it tests if those variables really influence the what? The said variable. Is that clear?
Yes.
Okay. So you have to know when you're studying these things. We can start with, for example, the one variable, one independent variable. Let's say what determines the salaries is just the education. I am asking you to follow nicely. Education. Okay, how true is this model? All right, what is the problem if you can just say the salary is heavily dependent on education? What do you think is a problem with this statement? Anyone? All right. Okay, so what you'll observe is that education is not the only variable that influences what? Salaries, right? We're just from listing other variables. So if you just say only education influences salaries, then you are omitting other important variables, especially that influence what? That influence salaries. So when we start studying econometrics, we will understand that the models that we use, the econometric models, of course, they can start with a single independent variable. And since it is not usually realistic for us to just use only one independent variable, you understand that there are other variables, okay, that influence those particular independent variables. So when you just put only one, there is a problem with the model that you are using. You need to introduce other variables that influence the other. So once you add the variables, okay, that influence this variable, it means that you have got a multiple regression equation, okay, or model. This is called a multiple regression model, where you have got more variables. It's a multi-variable one. You have a lot of variables trying to influence the dependent variable. And you see that the more variables you have, you're drawing closer to the true representation of the relationship between these variables and the outcome, or you are coming closer to the true representation of what happens or what influences the dependent variable. Are you following? Are the people following?
Yes.
Yes.
Okay, just need this introduction. It is very necessary. And so the more you add these variables, you know that the model that you will be dealing with will tend to be blue, right? To be blue simply means best, okay? This is best linear and biased estimator, which simply means that the model that you are using doesn't have much challenges. It doesn't have much variations or problems. So we are always encouraged that the model that we are using, I will show you that model, don't worry. The model that we are using should always have as many variables, of course, necessary variables, significant variables should always be there in the model to help us to at least report the reality, okay? Something that is closer to the reality. Not really the reality, but something closer to the reality. So you see that when you start adding now, someone will say, no, what influences the salaries is just education, okay? But someone will say, no, what influences education is the education levels, work experience, the age, the gender, and among other variables. At least that one who has mentioned many variables has said something that is closer to the reality, isn't it? As compared to someone who has just said only one independent variable. So you see that there is a problem in your model when you just use only one influencing variable, one independent variable. You need to introduce other variables. And again, the caution is that the variables that you are introducing should always be significant, should always be necessary to the model. So basically, we are trying in econometrics, we are trying to predict, okay, what the outcome would be, especially given the estimators. We estimate what the outcome of the other variable will be given the other influencing variables. I don't know if people follow.
Yes, we are.
We are.
Madam Nyambe, am I speaking so fast? No, sir,
No,
you are
no,
not.
you're okay.
Okay, so I am saying that econometrics is about finding out, okay? We're trying to find out this, the main skill that you need to get after the end of it all in econometrics. You need the ability to test the relationships that exist among the variables. You should be able to test the relationship that exists among the variables. You know, how does this variable influence the other variable, okay? That is all what you need. So that skill is what you should get from now. You will be given data, or you should be able to collect different data using those different techniques that you learned from statistics, right? From statistics, those different sampling methods, collect data, and after collecting the data, you should be able to regress the data and test the relationships using those models that you were introduced to, the econometric model. I will show you the model that I'm talking about. So you are interested in questions in econometrics such as, okay, what is the impact of exchange rate maybe on import demand? You use econometrics to help you to know the relationship that exists between exchange rate, or how the exchange rate influence the quantity of imports or the demand of imports. Is that clear? You may not know, if you are just quiet, how the exchange rates impact that, okay? But if you are given the data for exchange rates, you're also given the data for import demand. You're also given the data of other variables that influence the demand of imports. Then you can test now the impact of exchange rates on what? On import demand using the econometric models. Is that clear?
Yes, it is.
You will be interested in knowing and finding out the answers to the questions in economics, such as what is the impact of education on what? On salaries, okay? Is it really significant? Is it true that education has an impact? Now we have just said the education impacts, right? Has an influence on our salaries, but we don't know whether that is true until we test. Then the power to test is what you get in econometrics, okay? You'll be given the ability to test the relationship, to test whether the education really impacts on what? On salaries. You'll be given data on education, you get data on what? On salaries, salary scales, and other supporting variables, regress the equation, test the relationships, then you'll be able to say, indeed, education impacts on what? On salaries. Is that clear?
Yes.
So now, to predict this relationship, we need a predictor or an equation that should help us to predict the relationships between these variables. And those days back then in functions, you learned of this one. We have started. You learned of this equation, this function. Let me start from functions that you learned somewhere in primary school. F of x should be in secondary school, somewhere junior second. F of x is equal to, let me give you a simple fraction. 3 plus 2x, okay? So for f of x, let's put y. Let's say y is equal to 3 plus 2 what? 2x. My question is that, which variable between these two variables? You know that this one is a constant. It's called a slope, obvious. All the time it's called a slope, the constant. Then you have got the variable x here and the variable y. My question is, when you look at this equation, which variable influences the other variable? Which one is independent and which one is dependent? Formula. Which variable influences the other variable, x or y?
X.
X is the one that influences y, isn't it? You will see that, let's say x has not changed. X is 0. So what will happen to our y? Let's see what happens in the equation. We'll have 3 plus 2 times what? Times 0. Then our y will be equal to what? To 3, isn't it?
Yes.
Are we able to follow?
Yes.
Okay. What if now we change this x variable? We put, let's say, 3. What will be our y? 3
9.
plus 6, it will be 9. So you have seen that as x changes, y does what? Changes as well, right? So which means y is our dependent variable. It depends on the x variable. So this x variable is an independent variable, all right? It's the one that influences y. Is that clear?
Yes.
This is called the mathematical model, all right? It's the mathematical model, but from this one, now, we know when we are predicting the relationships between the variables that there are some errors that occur usually. We have the errors. For example, when you are maybe the errors can happen during the time of data correction, when you are correcting the data, or collecting the data, sorry. When you are collecting the data, you are gathering data. So you find that during data gathering process, maybe there are some errors, okay, that happens. Or maybe the way how you have stated that this variable influences the other variable is not really true. You have just you used only one variable, but there are other more variables that influences the other variable, right? So that means that in your model there is some error, okay? So that will help us to understand the introduction of an error term in the econometric model. Let's see now what happens. So we will have the constant being represented, let's say, by beta naught. This is our constant, okay? Then this slope be represented by bx, all right? Where x is the independent variable. Then we shall introduce this error term that I was talking about, epsilon. Is that clear? This error term, this E term that we have introduced now, is changing this model from mathematical model to an econometric model, okay? It has now become an econometric model because we have taken account of the errors, okay, that occur, especially when you are regressing these equations or when you are determining the relationships among these variables. Is that clear? Yes, this is called the error term. This is called the error term. It is also called the disturbance. It is also called the stochastic variable. Stochastic variable. Okay, remember those things, right? So what is there is that this one is always the slope, as you saw from that function that I showed you. That's a mathematical model. Then this one is the beta naught, which is a slope of a certain, it is a slope, the gradient of a certain variable that influences this y variable, okay? For example, we go back to our example of salaries. So you can say y is your salaries, right? Beta naught is the constant or the value of salaries when you have no education, zero education. Then beta 1, this one, let's say beta 1x. This beta 1 is representing the slope, okay, of what? Of education. Let's say the X variable now in question is education, which is the slope of education, or like the unit change in this Y, the salary, when X, or when a person increases the amount of education that they gain. Okay, let's measure education in terms of the year. When a person has just added 1 year into education, then the Y changes, right? Then the question is that by how much does the salary change? It changes by such units, the beta 1 units. Is that clear?
Yes.
Sorry to take you back, huh?
Yes, madam.
Yes. You said, can you go back on the beta 0? That's what you call beta naught, right?
The beta naught, yes.
Which is also a variable.
Yes, it's a constant.
A constant.
Yes,
Okay.
It's a constant of this function. I gave you this function first, 3 plus maybe 2x. So it's representing this one.
Okay.
How it is interpreted is the value of y when x is 0. In short, in case of salaries, we can say it is the amount of salary a person gets when they have 0 education. But the education that we are talking about is the years in education, formal education, of course. When they have not gone to school, there is some salary that they get, right? So
okay.
That is called the beta naught. That constant variable is constant. It doesn't change. So it's not influenced by what? By the change in X. Is that clear?
Okay.
Does that help?
Yes, it does.
Okay. So you've seen that we have introduced the error term. Now, the stochastic variable, its duty is to capture the variations that occur in this model. Okay. This model I have shown to you, it has got some errors. Just as I said, I talked about some few errors that happens when you're specifying the model. Okay, so there are some degrees of errors, okay, that we have in the model. Those errors are captured by this error term. Is that clear? They're captured by the error term. Okay, they are represented by this error term. This error term is not a number. Okay, as econometricians or economists and researchers have just agreed that let's put some variable to represent those errors. Since these models that we form are not really true representation of the reality, there are some errors. So let there be a variable that represents those errors. Is that clear? It's not a number. It will always be there, just like that, the error tree. So that is the econometric model. Now, follow nicely. We are getting there. Okay. The econometric model that I'm talking about, it has got what? It has got some properties, very, very necessary to notice. It has got some what? Some properties that are stipulated. Number one, this model, it is supposed to be unbiased. We'll talk about that in detail. Of course, you talked about this in statistics, that it is supposed to be unbiased. Okay, it is not supposed to be biased. And at the same time, we said that it is supposed to be efficient, right? The OLS estimator, OLS, ordinary least square estimator. It is supposed to be efficient, and it is supposed to be what? If it is supposed to be unbiased, it is supposed to be efficient. And what else is the property of this one? It is supposed to be consistent, isn't it? It is supposed to be consistent, meaning as the sample size increases, the sample size that you have gotten as you are researching, as it increases, this variable, okay, these variables, the beta ones, should start drawing closer and closer to the true representation or to the true value, okay, the expected value. You get it, right? As the sample size increases, then the beta naught or this value, the estimators should be drawing closer and closer to the expected value. Is that clear? We'll talk about those things in detail. I'll remind you in detail. Then after we have looked at these properties of this model, this same model that I was talking about, that is supposed to be blue, right? This model, beta naught plus beta 1 x plus the error term. It has got more versions. There is another version which is called a multiple variable. And when you add other variables to this model, when you say now what determines salary y, it is number one, beta naught will always be there, plus let's say education, which is the sensor for education, let's say x1, plus what else? You say the working experience. Let's say this is another variable. Let's say call it beta 2 and the x2. This one is the slope of that variable. Then plus what else? Gender. You said gender, that will be beta 3 plus x what? X times x3, the variable. This one is just the sensor, right? The gradient that shows us the unit change in y when this variable changes, when this x change. Then by how much does y change? It is represented by this one, beta 3. Then plus the error the error term. This is called a multiple variable model, econometric model, of course. Is that clear?
Yes.
Madam Mlenga, you are so quiet now. Am I Madam Nyambe? Sorry.
No, I was just trying to. I'm here.
Oh.
Hello? I was just trying to follow.
Okay, and relate.
Yes. Maybe you can go through again the first and the second one. The second one you said is a multiple variable.
Yes, when you introduce more variables that influence y. Then this one, this is when we just say only one variable. Like for example, when I gave you an example, I said, what influences salary is just education, which means we just have only one beta one like this and the constant.
Okay.
That would be the model that you're talking about. Is that clear?
That's clear. But what is the meaning exactly of the x?
The x is the independent variable. That's what we said. It's an independent variable in question. For example, you've said education, right? You have said education.
I understand now.
So this x is representing the education. How education impacts y? What is y? Salary, the variable in question that is being impacted. Clear?
Yes, clear now.
Okay. So from there, we understand that this model, after having the properties that we'll look at in detail, we will look at assumptions. There are some assumptions that have been laid by the econometricians and the economists and the researchers at large. As researchers, we have agreed that there should be assumptions that underpin or that guide these same models. Let me just give you this simple model, a simple linear regression model. This
Hello? Hello?
Hello? I think he's lost connectivity.
Oh, okay.
It's now on.
All right.
Hello?
Hello?
I'm back. I'm back now.
Okay.
I said, this model is guided by some assumptions, right? There are some assumptions that the researchers have agreed upon, that let's have the assumptions that should guide this model. Because really this model, it does not make sense without those assumptions, okay? So we start with making some assumptions that you get from statistics. For example, we understand or we assume that the data is normally what? Distributed. That is the assumption of normality, okay? We assume, I will explain in detail when I start teaching what this means. Normality, we have assumptions of, let's say, independency. These variables are independent of each other, okay? There is no autocorrelation, right? No autocorrelation between the variables, and there is no multicollinearity. There is no multicollinearity, okay? There is homoscedasticity. All those are key assumptions that we put around this model, okay? Those assumptions are the ones that we'll look at in detail. We'll look at these assumptions, how they work, and it will make sense to you why we should make such assumptions, okay? We'll give relevance to that. So In this course, from here, we'll learn now how to derive this equation. You learn how to derive this equation, this model, beta naught plus beta 1 x. You know, you will be given the values of x. For example, your x, let's say your x is education, isn't it? So you have a data of people and their years of education. You also have a data of their salaries, right? That is your y. Then you should be able to regress the equation and come up with the numbers here. This beta 1, beta naught is a number, just as you saw when I said 3x plus 2x, right, is equal to y. This is a number. We will regress the numbers that you are given, the data that you are given on x and the data that you are given on y. Then you come up with this number. We'll come here. This beta naught will be a number. Even this one, beta 1, will be a number here. Okay? Then the x will remain just like that. So you will learn how to come up with these numbers. Instead of just calling them beta naught, beta 1, you learn how to come up with them. That's the deriving this model. You learn how to specify the model, okay? And what happens when we add more variables to this model, and why you should actually add more variables. You learn how to test whether the model is a true representation of the reality or it has got more errors. You learn how to minimize the errors in the model, because you have to minimize the errors. Your target is to minimize the error term. So how do you minimize that? That is what you will learn. You will learn from there. We introduce you now to the statistical packages, because you learn that what you are doing is actually a lot of work. You cannot deal with these things, these calculations using your hands. You can just deal with calculation when you're doing with only a simple model, this one, where you have just beta naught plus beta 1. You can use your hands, given the data for x and given for y. But there will be the time when you're dealing with a lot of what? Variables, right? Just as I said, when you introduce more variables, you will not manage to use your hands. You need to use a computer, okay? So there are some statistical softwares or packages that are there to help you to regress and come up with these equations. Calculate the beta naught for you, calculate the beta 1 for you. The computer does it for you, okay? So the statistical packages that you have to learn start from Stata, right? We introduce you to Stata so that you learn how to use a computer to do work for you in econometrics. Most of the work you do in econometrics, the computer should be able to do for you. We introduce you to e-views. We'll introduce you to Arion, okay? If you have time, we'll introduce you to some more other, but I will maybe comment just on the two, looking at the time that we have and how to use them. Then once you are able to regress the equations, you will be able to have the output from the computer and just interpret, okay? Just interpret, get the figures, fix into this model, and you have the numbers here, okay? You have the numbers here, just like that. That is how you come up with what? With the model. You will learn how to test hypothesis after that now. I'm sure you did hypothesis testing in statistics. It will come again. That is very, very important. But you do that after you know the output from the computer. How do you interpret? How do you test the hypothesis? For example, how to use the p-value, how to use the t statistics, how to use the z statistics, how to use the confidence interval. Those things you did them in statistics, but now, in that time you are using your hands in statistics, but now you use the computer to do that, and you just interpret. And that is what will happen from there. While we introduce you to the dummy variables, okay? We introduce you to the dummy variable. Now the dummy variable simply means, what if the variable that you're dealing with has got two sides? For example, you're dealing with with gender. Gender is a dummy variable. You can have male or female. When you ask a person, you go to ask, are you male? Are you female? Okay. The answer is yes or no, isn't it? If a person says yes, then you put 1. If a person says no, you put a 0. The dummy variables are called the categorical variables. You look at the behavior of the dummies, the dummy variables, how they work and how they influence the model. After I have introduced you to the dummy variables, we'll look at the other econometric models, such as the linear probability model, LPM, the logit model, I'm sure you saw those things on your course outline. Logit model, the probit model. These are other models, the econometric models that you have to learn. And then we'll look at the types of data, right? The different types of data. The types of data that we'll look at are the following. We'll start with the cross-sectional data, cross-sectional data. Then from the cross-sectional data, we'll look at the panel data, all right? Then we'll look at time series data. Time series data. I will explain them in detail when we just zero in. After we have looked at these models now, you remember those assumptions that we had laid about the model, right? There are some assumptions that we had laid about the model. Mr. Moses?
Yes.
Am I not confusing people?
No, we are following.
Okay. These assumptions such as normality, homoscedasticity, among others, those assumptions, right? We'll relax them now, later on. We'll start violating them. Let's assume there is an assumption of normality, isn't it? Like the data is normally distributed. Then the question is that, assume now the data is not normally distributed. That's violating the assumption. Then we'll ask ourselves, what happens when you violate those assumptions or when you relax the assumptions? Okay. Homoscedasticity, we say to all the data sets, all the variables, the variance is constant, right? That is homoscedasticity. Assume now that the variances are different. They keep on changing to each variable. What happens? Okay. Multicollinearity. What happens if there is a relationship between what? The independent variables. What if they are related? What do you do? So you learn how to correct. You relax the assumptions. And then the question is that in case you find that these variables, there is a heteroscedasticity, that simply means the variances are not the same for the variables. Then the question is that, what do you do? How do you correct that? You should learn how to correct that, how to correct these violations that you make. Yeah, you should be able to learn, especially how to use this theta, E-views, and Arion, among other statistical packages. Maybe the question is econometrics important? How important is econometrics? Yes, sir, it is very important. In your research, you will use econometrics to conduct your research. You know that you cannot graduate with a degree without research. Either bachelor's degree or what degree or any other degree, you cannot. You need the research. So for you to research, especially quantitative research, you need this knowledge that we are teaching you in what? In econometrics. So you have to hold econometrics with all your power. That is the one that will help you now to research. Because in researching, you have questions such as, what is the impact of inflation on import demand? Since you know how to test those relationships or those impacts using econometrics, it will be very easy even doing research. Your research will be very easy and it will be very interesting. You enjoy your research. But if you don't understand econometrics, research can really give you hell. It will give you much pressure. So that's why I'm saying in conclusion, econometrics helps us to understand what research and appreciate research because it's heavily used in quantitative research. Any question?